Hello everyone. Today we'll be talking about business intelligence systems for fraud detection. Fraud is a significant and costly issue across many industries. These industries can include finance, e-commerce, and insurance. Now, a traditional limitation is the rule-based system that is rigid and can miss subtle fraud patterns. A solution to this is combining machine learning or ML models with business intelligence or BI tools for a dynamic and adaptive fraud detection. Usually, ML models, such as decision trees, neural networks, learn from historical fraud patterns. From these patterns, they help identify subtle trends and outliers in real-time data and predict the probability of fraud and flag suspicious activities. Now, there are three benefits to ML-powered fraud detections. They help reduce false positives and negatives. There is a proactive identification of emerging fraud schemes. And there is improved decision making with a faster response time. Now, once ML is integrated with BI, there will be visual dashboards for real-time insights and anomaly detections, as well as collaborative platforms for fraud analysts, risk managers, and decision makers to help streamline operations and help improve communication. Now, there are two things to consider. One is data processing. Data processing requires robust infrastructure, such as cloud and or big data systems, to handle large volumes of data. The second consideration is model maintenance. Having continuous training and improvement are essential to adapting to evolving fraud tactics. The role of business intelligence tools. Now, there are three central functions. The first function is having real-time dashboards for monitoring flagged transactions. BI tools also have interactive visualizations to track fraud metrics such as risk zones and patterns. And the last essential function is the integration of ML models for real-time updates and insights. Two BI tools that will and can be used are Power BI, which is customizable dashboards with fraud heat maps, and Tableau, which has visualization of anomalies, trends, and heat maps as well. The demonstration or steps for ML models in BI tools. The first step is data input. ML models will use historical data on transactions, customer behaviors, and fraud cases. And once integrated with BI, it will help find real-time data feeds from payment gateways or user activity logs. Step 2 is machine learning in action. The first part, step 2, is training the ML model on historical fraud patterns. From this, we can generate fraud scores for new transactions in real time. Step 3 is visualizing insights with BI tools. First is Power BI dashboards. Two things we can do is fraud score distribution. This can be shown as a bar chart which has flagged transactions by risk score. Second, historical trends. This can be shown as a line graph comparing fraud rates over time. Moving over to Tableau, in Tableau we can use a transaction heat map. If you look over at the image on the right, you'll see a geographic representation of fraud hotspots. By looking at this heat map, we can see which states have higher activity of fraud. Second, in Tableau, is fraud prediction accuracy. This can be shown as a pie chart using success rates of the ML model. Now, the challenge of credit card fraud. Credit card fraud is a significant and evolving threat to financial institutions. Now, the traditional rule-based systems have their limitations, such as a high false positive rate and the inability to detect sophisticated fraud tactics. Now, there are 3 consequences to this. These consequences are financial loss, reputation damage, and eroded customer trust. Now, to further understand, we will use a scenario. In this scenario, a bank uses ML and BI tools to monitor millions of daily transactions. Beginning the workflow, the ML model identifies a transaction from an unusual location as suspicious. From here, BI dashboards such as Power BI and Tableau highlight the flagged transaction with supporting data, such as previous locations and an average transaction size. From here, a fraud analyst reviews the case and decides to plug the transaction in real time. There are 2 outcomes that can happen. The first outcome is reduced financial loss and improvement in customer trust. The second outcome is lowered false positive rates and ensuring seamless customer experience. Benefits and conclusion. Benefits of integrating ML and BI tools. Again, there will be an enhanced fraud detection accuracy with fewer false positives and negatives. By having real-time insights, this will enable faster decision-making. Another benefit is scalability for large datasets and evolving fraud tactics. There will also be an improvement in collaboration among fraud analysts and decision makers using the shared dashboards. To summarize, the impact of ML models and BI tools will revolutionize fraud or credit card fraud detection. There is a highlight with the importance of continuous learning and real-time collaboration. And lastly, this will encourage adopting this integrated approach for robust fraud prevention and operational efficiency.